what do you think about this?
About acids and
No, respiration. What is the role of respiration in balance of acid and base? You can give two attendants together. My attendance and this attendance you can give together. What is the main thing for the maintenance of
It's maintaining balance between oxygen
oxygen and carbon dioxide?
and
Okay.
H.
Okay. So how the oxygen and carbon dioxide? You don't want to attend? I told him he can give two attendants together. So what is the role of how the carbon dioxide and oxygen is transported?
Oxygen it has a schedule from 100 to 60 minutes.
You didn't understand the question. How the oxygen and carbon dioxide is transported in our body?
Expiration. Hemoglobin.
Hemoglobin.
Yeah.
Yes, very good. Hemoglobin is play a very, very important role for maintenance of acid-base balance through respiration. Through respiration. So in the lung, the oxygen is totally bound with hemoglobin. Fully saturated. Why? Because the partial pressure of the oxygen in the lung is high compared to peripheral tissue. Because we are inhaling gases. That gases is having more amount of oxygen. So that's why the oxygen is bound with hemoglobin. And then it goes to serious class. Then
Tissue.
through where?
From heart to the organs. Tissue.
Lung to which part of the heart?
Left atrium.
Left atrium, good. Then left atrium to left ventricle. Then arch of aorta to rest of the body. When it is reaches to peripheral tissue, where the oxygen concentration is less, but all the metabolism is occur in the peripheral tissue. Like what are the metabolisms is occur in peripheral tissue? For example, in your muscles,
Energy production.
skeletal muscles,
Energy production.
Which lecture?
Energy production.
Energy production. Very good. So by the end of energy production, what is there?
Lactic acid. Lactic
No,
acid.
lactic acid is abnormal condition, not the normal. I am talking about normal. ATP, okay, very good. Tani?
Provate. Provate.
ATP is the last, is right. And carbon dioxide is. So that carbon dioxide has to be transported from peripheral tissue to lung. So oxygen is released from hemoglobin and then bound with which protein is present in the muscles?
Actin-myosin.
Myoglobin. Myoglobin. Okay. And then hemoglobin bound with carbon dioxide and enters into veins. Through the veins it reaches to right atrium, right ventricle and then lung. In this way the whole cycle is occur normally. So by this way the oxygen is transported from lung to peripheral tissue and carbon dioxide is transported from peripheral tissue to lung. Okay, this is brief introduction. So let us start. Some explanation is on the board and rest of the things is present in this PowerPoint. So in the lung, hemoglobin plus oxygen. Okay, to form, I think physiology people taught this. Oxy, hemoglobin. So this oxyhemoglobin is how the oxyhemoglobin is formed. How many oxygen has to be bound with hemoglobin?
Four.
Good. So four oxygen has to be bound with hemoglobin. For example, this is one hemoglobin. Hemoglobin is having, what is hemoglobin first? Very good. This is a conjugated protein. Heme plus globin. So heme is non-protein part, globin is protein part. 2 alpha unit, 2 beta unit. Okay. So this alpha, beta, beta, along with the iron which is present in phosphate. Okay. So this first hemoglobin bind with oxygen to form oxyhemoglobin, but that is only one hemoglobin. Okay. Then second hemoglobin is added to same second oxygen is added with same hemoglobin to form another. In this way, through the 4 step, 4 oxygen molecule is bound with
The same way.
hemoglobin. Yeah, but the mechanism is different. I will tell you. So one hemoglobin bind with first oxygen, it helps in the binding of second oxygen with the same hemoglobin. For example, here the affinity of oxygen binding with hemoglobin is 25%. So here is 50%, here is 75%, and here is 100%. So this mechanism is called heme interaction. Heme interaction or cooperativity of hemoglobin with binding of oxygen. Okay. So here in the lung, the whole maximum amount of oxygen is present. So this reaction is occurs within seconds. Within seconds. When the person goes to high altitude, okay, that time some, not all, some of the patient feeling breathless because oxygen concentration is less. So this phenomena is slow because of oxygen concentration is less. The oxygen binding with hemoglobin is less.
It's called heme interaction.
Yeah.
It's with oxygen, just with oxygen.
Yes, with oxygen.
With carbon dioxide. It's what's called.
So this whole mechanism is called Hall-Dann effect. The binding of oxygen with hemoglobin in the lung is called Hall-Dann effect. So this in the lung, then oxyhemoglobin is entered into arterial blood. Okay, then it goes to peripheral tissue. In the peripheral tissue, there is a myoglobin. Hemoglobin is tetramer. Myoglobin is monomer. The first difference. And here, the affinity of oxygen to hemoglobin is less compared to myoglobin. Here, the partial pressure of oxygen is more, but here partial pressure of oxygen is less. But affinity is more. So that's why whenever the oxygen is released from arterial blood to peripheral tissue, is scavenger, means immediately captured by myoglobin. So this myoglobin bind with oxygen to form oxymyoglobin. So this oxymyoglobin is utilized for cellular respiration. Cellular respiration. As you told, to form, most important thing is ATP, then carbon dioxide, then hydrogen. Okay, so this carbon dioxide and hydrogen ion further help in release of oxygen from hemoglobin. Okay, so one hydrogen bond with hemoglobin leads to release of two oxygen molecules. One hydrogen bond with hemoglobin helps in release of two oxygen molecules. So that's why hemoglobin is act as a buffer, because it binds with hydrogen. What is buffer?
Balance.
Definition of buffer: any substance which resists to change in blood pH. To change in blood pH is called buffer. Right? So here hemoglobin is binding with hydrogen and that resists in change in blood pH. If hemoglobin is not bound with hydrogen, so hydrogen concentration is increased. So pH is changed. So that's why the hemoglobin is act as a buffer. Hemoglobin is act as a buffer. So one hydrogen bind with hemoglobin leads to release of two oxygen. So two hydrogen bind, release of four oxygen. Okay, mafhum? Okay. So this carbon dioxide, for example, this carbon dioxide is 100%. Okay, out of 100% is 15% bind with hemoglobin. 15% out of 100%. Out of 100%, 15% bind directly with hemoglobin, and rest of the 85% of carbon dioxide diffuse, or I can say enter into RBC. 85% of carbon dioxide enter into RBC. Okay, so this 15% binding of carbon dioxide directly with hemoglobin also help in release of oxygen from hemoglobin. So this hemoglobin is called oxyhemoglobin. After binding carbon dioxide with hemoglobin is called carbamyl hemoglobin. Carbamyl hemoglobin. Binding of carbon dioxide with hemoglobin to form carbamyl hemoglobin. Binding of oxygen with hemoglobin is oxyhemoglobin. So this carbamyl hemoglobin and these things goes to lung and then other reaction is occurred. So this release of oxygen at the tissue level because of hydrogen, carbon dioxide and ATP, this is called Bohr effect. Bohr effect. And here also ATP, carbon dioxide, hydrogen and some other metabolites is also help in release of oxygen from oxyhemoglobin to myoglobin. Okay, and here this 85% of carbon dioxide which is enter into RBC, Duster. RBC is having aerobic respiration or anaerobic?
What is it?
RBC.
Aerobic.
Huh?
They need it.
Aerobic or anaerobic? Huh? Aerobic. Less aerobic. Need oxygen, okay. But aerobic or anaerobic? Mitochondria is there in RBC? So less aerobic. Huh? So this 85% of carbon dioxide which is entering RBC. So this carbon dioxide, water is available everywhere in our body, right? So this carbon dioxide bind with water to form carbonic acid by enzyme carbonic anhydrase. This carbonic acid is further split into hydrogen ion and then bicarbonate. Okay, and this bicarbonate is very important that enter into plasma. Okay, and then to maintain electrical neutrality. So chloride from the plasma is shipped to RBC. RBC, chloride is from plasma enter into RBC and bicarbonate from RBC to plasma. So this mechanism is called generation of bicarbonate by RBC, or you can say chloride shift. Chloride shift. So in this way you cannot say carbon dioxide is not useful. Carbon dioxide also play very important role in our body because 85% of the carbon dioxide which is produced at cellular respiration is entered from blood to RBC. In RBC, carbon dioxide bind with water to form carbonic anhydrase. Carbonic anhydrase to form carbonic acid. This carbonic acid is split into hydrogen and bicarbonate. This bicarbonate is very important in our body to maintain blood pH. Blood pH. So that's why this bicarbonate enter from RBC to plasma. And then to maintain balance, chloride is enter from plasma to RBC. Plasma to RBC. This whole mechanism is called generation of bicarbonate by RBC or chloride shift. So in this way, the acid-base balance is maintained. One is by hemoglobin to capture hydrogen. This hydrogen is taken by hemoglobin and carbon dioxide is converted to bicarbonate. So they play very important role in our body to maintain normal blood pH. Okay, and this blood is venous blood. So the concentration of chloride ion in venous blood is more compared to arterial blood. Concentration of chloride ion in venous blood is more compared to arterial blood. Okay, the first reaction which is occur in the lung is Haldane effect. The second reaction which is occur in the peripheral tissue is Bohr effect. So whenever any respiratory disease, wherever the concentration of the carbon dioxide is increased in our body, that leads to respiratory acidosis. When the carbon dioxide concentration is decreased, okay, that condition is called respiratory alkalosis. Respiratory alkalosis. If carbon dioxide concentration is increased, means the production of this bicarbonate is more, carbonic acid is more, and that indirectly leads to increase in hydrogen ion concentration. 7.
It's acidosis, there was
Increase in carbon dioxide concentration, decrease in pH, decrease in pH. Okay. So here carbonic acid is more, because more carbon dioxide, more carbonic acid. If more carbonic acid, more hydrogen ion. Bicarbonate is there, but that is entered into plasma. Okay, and this hydrogen ion is more, so that leads to decreased pH, increased PCO, that is acidosis. I told you last year one abbreviation, ROME. Okay, Rome. Respiratory is opposite. Metabolic is equal. And metabolic is always with bicarbonate. And respiratory is always with carbon dioxide. Okay? If carbon dioxide is increase, opposite, pH is decrease. If carbon dioxide is decrease, pH is increase. Okay? If carbon dioxide is increase, that is respiratory acidosis. If carbon dioxide is decrease, that is respiratory alkalosis. Metabolic, if bicarbonate is increase, pH is increase, that is metabolic alkalosis. If bicarbonate is decrease, pH is also decrease, that is metabolic acidosis. Okay, so this is the some part of lecture. So let us start. Huh? So these are your objectives. Define respiratory acidosis and alkalosis and their causes. Explain the interrelation between the bicarbonate and partial pressure of carbon dioxide. Explain the important role of compensatory mechanism in respiratory acidosis and alkalosis. Interpret the result of arterial blood gas analysis. Describe the role of respiration in acid-base balance and chloride shift. So this is just introduction. Definition: pH. pH is mathematically defined as negative logarithm of hydrogen ion concentration. It provides convenient way to stating hydrogen and hydroxyl concentration. Is devised by Sorensen, a scientist name. Okay, pH range, as all of you know, from 1 to 14. 7 is the neutral. Acidic solution is pH is less than 7. Basic is more than 7. Total is 14. The pH of the blood is 7.35 to 7.45. So every student should know about this. What is the normal blood pH? pH is less than 7.35 is acidosis, more than 7.45 is alkalosis. Life is compatible with pH range 6.8 to 7.8. Person can live pH between 6.8 to 7.8. If less or more, he will die. Why we need acid-base balance? Proteins and enzymes need a narrow and optimum pH range. If the pH range is changed, all enzymes in our body is inactive. So enzymes is inactive means maafi shukr, kullu kharban. Okay. Denaturation of protein is occur, inactivation of enzyme. Then carbon dioxide and bicarbonate substitute, and this equation by which you can find out any fluid in our body, the pH. So for example, here this equation is it's called Henderson-Hasselbalch equation. So please inform your classmates if they come to my office to explain all these things. I am not going to explain them because I am busy in my block, IMS, nowadays. So please convey this message, especially some of the students. You know, they are always teasing me, explain. They are absent in the class. This is not a joke. So pH is equal to pKa plus log is base by acid. pH, as you know, negative logarithm of hydrogen ion concentration. pKa means dissociation constant of acid. Any acid, okay, and plus log base by acid. Here also any base, any acid. So let us take example here, bicarbonic acid. So pH we have to find out. Dissociation constant of bicarbonic carbonic acid is 6.8. 1 plus log base by acid. Base is normal concentration of bicarbonate is 22 to 26. So we are taking average 24 divided by 1.2. So this is acid, carbonic acid. So we put value 6.1 plus log. Haza, if you cancel 24 divided by 1.2. If you remove this fasala, so here 0. Haza 1, haza 2, 0. So 20 by 1. So log 20 is equal to 1.3. If you add 6.1 plus 1.3, you will get 7. Okay? So it is evident that at blood pH 7.4, the ratio, this point is very important. The ratio of bicarbonate to carbonic acid is 20:1. So always base is more in our body normally, 20 times more than acid. So this high concentration of bicarbonate,
same
what are it? 20:1 as a bicarbonate as a hydrogen. Acid means hydrogen. Okay, so this is called alkali reserve. Alkali reserve. Alkali reserve is very important to maintain blood pH, because whenever the cellular respiration is occur in our body, the hydrogen ion is produced. That hydrogen ion is immediately neutralized by excess of this bicarbonate, because 20 times more bicarbonate compared to hydrogen. So whenever normally in our body hydrogen ion is produced, so that has to be neutralized by this excess of bicarbonate and try to maintain blood pH normal. Okay, so this is about alkali reserve. So normal when acid base disturbance. So there are two types: respiratory acidosis and respiratory alkalosis. Respiratory acidosis and respiratory alkalosis. So respiratory acidosis means increase partial pressure of carbon dioxide and decrease pH. Here decrease partial pressure of carbon dioxide and increase pH. Okay, so whenever this occur, some of them are causes. For example, any obstructive disease of the lung like asthma, okay, and COPD, chronic obstructive pulmonary disease, like emphysema,
Bronchitis.
Mashallah. Chronic bronchitis, bronchiectasis. Bronchiectasis. Sometimes, if the lung is very big, lung cancer is very big, or sometimes the foreign body is entered into the lung that block the main bronchus. So that also leads to obstruction. So any airway obstruction disease leads to respiratory acidosis. Respiratory acidosis is usually occurring hypoventilation. Hypoventilation means decreased rate of respiration. Decreased rate of respiration. The opposite is here. Hyperventilation. Hyperventilation, where the respiratory rate is increased. For example, causes brain tumors, some drugs, okay, and hysterical attack, especially in female. Okay, they are taking respiration like that. If something is against them, usually you can find out in your family or sometimes when you enter into the hospital, especially in the night, you find some cases like that, especially in female. They are taking hyperventilation that leads to respiratory alkalosis. Okay, so these are the two conditions. Respiratory acidosis means partial pressure of the carbon dioxide is increased and pH is decreased, because respiratory is opposite, metabolic is equal. And this alkalosis is partial pressure of carbon dioxide is decreased, pH is increased. Here is hyperventilation, here is hypoventilation. So, but in our body there is a compensation is occurring. Compensation. What is compensation?
Correction.
Balance.
Correction. Try to correct to certain limit. If correction is possible, okay, person can live. If correction is not possible, person may have changes in their body. So, respiratory acidosis and alkalosis is compensated by, yes, very good. And metabolic?
Metabolic ventilation.
Yes, through lung. Through lung.
What did you?
Lung.
Roda?
Ventilation means lung.
Yeah.
Metabolic is compensated by respiratory mechanism, and respiratory is compensated by renal mechanism. So next year you will study about how the kidney is responsible to maintain acid-base balance. Unfortunately, I am not here. Somebody is going to talk it.
Why this?
I am going, alas. So compensation by kidney. For example, respiratory acidosis. In respiratory acidosis, the partial pressure of carbon dioxide is increased. So hydrogen is increased or decreased?
Decrease.
Which decrease?
Opposite.
Decrease. And pH is decrease. So this hydrogen is more in our body. So that's why we have to remove it. So through the kidney, the hydrogen is secretion is increased. Hydrogen excretion. Increase bicarbonate reabsorption. Is increased. Hydrogen excretion. There is a difference between excretion and reabsorption. Excretion means ikhraj. Mafi ifras. Ikhraj. Hydrogen ion excretion is increased to decrease the concentration of hydrogen ion in our body. And bicarbonate reabsorption is increased to neutralize the hydrogen ion content. If kidney is normal, So this compensation is occurred. But at old age people, usually the multi-organ failure, not only one organ, multi-organ failure is occurred. So in those conditions, this compensation is failure. This compensation is failure, and that leads to the disturbance in acid-base balance. But you have to treat them and try to maintain blood pH. For these cases, you have to give bicarbonate IV. Bicarbonate IV and try to neutralize the hydrogen ion concentration. So this is about acidosis. But alkalosis, fully reverse. Alkalosis, the PCO2 is decreased, hydrogen ion is decreased, and this increase. So kidney hydrogen ion excretion is decreased, and bicarbonate reabsorption is decreased. Okay. So in this way, the hydrogen excretion decrease means hydrogen is accumulated in body, and bicarbonate reabsorption is decrease means it has to be eliminated in the urine. So in respiratory acidosis, urine is acidic. In respiratory alkalosis, urine is basic. So in this way, the compensation is occur normally in our body. If kidney is normal, if kidney is abnormal, this compensation is doesn't occur. Okay. So let us come to arterial blood gas analysis. A, B, G. This is called arterial blood gas analysis. This is only one investigation you will get arterial blood. Rest of the investigations you need venous blood. But this investigation you need arterial blood. You have to collect blood from peripheral arteries like radial artery, femoral artery, sometimes dorsal spines. Okay. So here normal values, I am talking about the normal. pH 7.35 to 7.45. PCO2, partial pressure of oxygen, is 80 to 100 millimeter of mercury, and partial pressure of carbon dioxide is 33 to 44. It differs from books to books, don't worry. Okay, and bicarbonate is 22 to 26 milli equivalent per liter. Sodium 135 to 145 milli equivalent per liter. Potassium 3.5 to 5 milli equivalent per liter. Chloride is 96 to 106 milli equivalent per liter. So everybody should know all these values. Okay. So this is about normal. So for example, pH This is very, very important if anybody want to work emergency department. You should be thorough about this. Otherwise, patient will die. If you don't know this, you cannot able to treat, patient will die.
If there is reference value, they put it in
Normal variation.
the levels of there is reference value.
Yeah, but you have to able to diagnose. Reference value is there. This reference value is here and here. This is patient report. This is reference value. So you have to able to diagnose. So that's why I wrote first normal. Yes. If carbon dioxide is more, what do you call that condition?
What?
No, in general, physiological.
Kidney.
Hypercapnia. If oxygen is less,
Hypoxia.
hypoxia. Okay. Now tell me, pH is less or more?
It's
Normal.
This 7.3. Huh? 7.35 to 7.45. Little change is also mushkil. Huh? This is decrease. Good. This is decrease. Increase. This. Huh?
Decrease. Lower than decrease.
Decrease. This is?
No.
No. Tell me, what is your diagnosis? pH is decrease. Carbon dioxide concentration is increase.
Respiratory acidosis.
Respiratory
Acidosis.
acidosis. Respiratory acidosis.
hydrogen means acid.
Yeah. Okay. pH is related with hydrogen.
Yeah.
And here pH and carbon dioxide. Reverse relationship.
Yes.
pH is decreased, carbon dioxide is increased. So this is respiratory acidosis. This one
Alkalosis.
increase as a normal, as a
Increase. No, it should be increase. Metabolic alkalosis.
30 increase. This
No.
no. So
Metabolic acidosis.
respiratory
Alkalosis.
alkalosis. Now here
Decrease pH.
pH is
Decrease.
decrease. This is normal. This is normal. This one
Decrease.
decrease. So
Metabolic acidosis. Acidosis.
metabolic acidosis. This
Increase pH.
increase, normal, normal, as a increase.
Metabolic alkalosis.
Metabolic alkalosis. And one important thing you have to remember, whenever the acidosis is occur, hyperkalemia is there. Hyperkalemia. Whenever the alkalosis is there, hypokalemia. Kalemia means
Potassium.
potassium. How weights here are the different. Okay. This is extracellular fluid. This is intracellular fluid. Whenever the acidosis, the hydrogen ion concentration is more in extracellular fluid. Okay, and potassium is always present in intracellular fluid. So that's why hydrogen is more dangerous compared to potassium. So that's why this is a compensation. The hydrogen is going from extracellular fluid to intracellular fluid, and potassium is coming from intracellular fluid to extracellular fluid. So this reaction is occur in acidosis. Okay, reverse is in alkalosis. Reverse is in alkalosis. So that's why in acidosis always hyperkalemia is there. In alkalosis hypokalemia is there. Okay. And another thing here, these are called electrolyte.
Yeah.
Electrolytes. There should be a balance. But some of the negative charge ions we cannot able to measure. Why? Because proteins is having negative charge amino acid. We cannot able to separate all proteins and get amino acid and to measure it. Okay, so that's why it's called anion gap. Anion means negative. Cation is positive. So anion gap means if you calculate this, this is cations. This is anion. Sorry. Cation is this one. This cation. Cation is positive charge. Sodium and potassium is positive charge. And bicarbonate and chloride is negative charge. This is called anion. So for example, we take average cation equal to anion. So for example, cation is, I will take this 135 plus 5. So it will become 40. Right? Cation is, I will take this 106 plus 24. So cation are 135 plus 4 is 139. Anion is 125 is 125. If you minus this, how much is remain? 14. So here is anion gap is 14. So normal anion gap, it should be between 11 to 18. This is normal. If any change in this anion gap, so that leads to electrolyte imbalance in our body. Anion gap means there is a total measurable amount of cation minus total measurable amount of anions. So there is a gap because we cannot able to measure some of the anion in our body. So normal range is 11 to 18, or some books says 14 to 18, like that. So if in this range, it is okay, well and good. If it is increase or decrease, that leads to imbalance. So this is all about today's lecture. So please, everything is there except first explanation. First explanation. Okay. So you have to read it. If you have any doubt, bus this 10 students. Come to me, I will explain. I am not going to explain anybody else. Okay? Yes. Give me pen.